Once upon a time, a man was sitting under an apple tree, and he watched an apple fall, and it would have been a pretty insignificant moment had the man's name not been Isaac Newton. So, Isaac Newton. I'm sure you all know him. Reader, writer, philosopher, mathematician. Pretty cool guy. But today we're going to be talking about his most famous discovery of all, Newton's three laws of motion. Newton's first law of motion, also known as the law of inertia, states that an object at rest shall stay at rest, an object in motion shall stay in motion, and that they should only change state if acted upon by an equal or opposite force. There are two things I want you to take into account when I explain this. One, every object has an innate sense to resist change in state. And number two, I want you to think of inertia as stored energy, how much energy an object has stored. Take a roller coaster, for example. You're all getting in, it's stopped. You're in the loading bay, it's stopped. Everybody's getting in, loading up. Everybody gets their seatbelts buckled, then the motor kicks on. And that roller coaster starts rolling forward. That's because the force that was being applied was able to override the roller coaster's force of inertia reluctantly and began moving it forward. Then you start climbing up the hill, you get to the top, you crest over, and you start going down. Once you start going down, the roller coaster starts rapidly storing energy. And once you level out, it begins to spend that energy. The roller coaster keeps moving. Eventually, the roller coaster will stop, due to opposing forces such as, drag, friction, gravity, that kind of thing. But it stores energy to remain in its state of motion. And, when it's at rest, it has no energy, so it doesn't take a lot to get it into motion. Once it's in motion, it really wants to stay in motion. Let's talk about the second. Newton's second law of motion states that force is equal to mass times acceleration. What exactly does that mean? Well, it means I think it's pretty simple. It means what it means. The force being exerted on an object is equal to its mass times its acceleration. Take me, for example. Let's say I weigh 80 kilograms, but I'm not accelerating. What's 80 times 0? 0. There's no force being exerted on me. But then let's take the moon, for example. Right? Let's say for simple, we'll do nice even numbers. The moon weighs 10,000 kilograms, and it's moving at 5 meters a second squared. What's 10,000 times 5? 50,000. The moon has 50,000 newtons of force being exerted on it. It's a lot. It's a lot, right? And Newton's second law will actually lead us into his third. So let's take a look at that. Newton's third law of motion states that for every action is an equal and opposite reaction. Now, most people think of it in the karma type of way. If I don't open a door for somebody, somebody's not going to open it for me. And while that's a good positive train of thought, that's not exactly how it works, right? The way it works is that for every force exerted on an object, let's say I push on this wall, it gets exerted back on the object. So if I push on the wall with 10 newtons of force, the wall is going to push on me with 10 newtons of force. A good example is the Earth and the Moon. The Earth and the Moon push and pull on each other all day long, 24/7, 365, right? And you got to think, the Earth weighs more than the Moon, doesn't it? How do they pull on each other with the same amount? And that ties back into Newton's second law of motion, of force being equal to mass times acceleration. So while the Earth may be 50,000 kilograms and moving at 2 meters a second and having a total force of 100,000 newtons, the Moon would be having to move at 10 meters a second if it's only 10,000 kilograms. And that is actually the cause for the orbiting of the Moon. That's why the Moon orbits the Earth, which I think is pretty neat. If you're watching this, I hope you enjoyed the video. Shout out to Mr. Johnson in case this blows up. Thank you for watching.